Hello everyone. Today in this video lesson we would like to talk about what is an electric flux is. We know around a charge there will be an electric field, and to study how strong the field is or to how weak the field is, we need to use a concept of electric lines of force. And to measure it even in a more accurate and a comfortable way, we are introducing a term like electric flux. It is simply defined as, in the meaning and understanding sense, a number of electric lines of force. Number of electric lines of force. Electric lines of force are the imaginary lines that starts from the positive charge and ends at the negative charge. Electric flux is defined as number of electric lines of force either coming or else going into a field or into a surface, in or out of a surface, and of course it is normal to the surface. Normal to the surface. We want to write a mathematical equation for this electric flux. It is mathematically defined in the following way. Say for example, we are having a body something like this, a surface. Let in that surface we are having a charge. I am interested in knowing what is the flux due to this. To know the flux due to this, we shall consider a small surface area. A small surface area. We know the surface area behaves like a aerial vector. The direction of the aerial vector is always radially outward direction. Radially outward direction. Now we have a choice that how we are applying an electric field. Say for example, we are applying an electric field like this. It is very clear that the electric field is making some angle with the aerial vector theta. That means entire E is not acting along the direction of aerial vector, rather only a component of that is acting. We can simply calculate the component as what? I can resolve this E into components. I can say along the aerial vector E cos theta is acting. Perpendicular to the aerial vector E sin theta is acting. But it has no role to play. It is not going to create any flux or else a field. So electric flux is defined as, electric flux is mathematically defined as, you can say d phi or else a delta phi as the entire aerial vector delta s multiplied by the component of the electric field acting along it, E cos theta. We can say it even in the reverse also, that in the direction of the E only a component of aerial vector is acting, and I can write delta s cos theta and E, both of them are going to remain same. So it is a dot product of two vectors, that is nothing but equal to E dot ds. As it is a dot product of two vectors, this is going to be a scalar quantity. So flux is a scalar quantity and it is defined as a dot product of electric field vector and the surface area element at a particular point, right. Anyway, it is only a small component. If I want the total electric flux due to all the surfaces, there are so many surfaces, each surface has to be calculated, each flux has to be calculated. Then I have to get all of them, we have to integrate the equation. So what I have to say now? To get total flux, I have got only a component of the flux due to a small charge. Now I am interested in getting the total flux. Integral of d phi is integral of E dot ds. Integral of differentiation of the flux is nothing but equal to flux. That is nothing but equal to E dot ds. This is how we can calculate the flux over a curved surface or a given surface. This is how we can find the electric flux of a given surface. We need to further understand that if you are considering a positive charge in any of the closed surface, then electric lines of force due to this positive charge will be coming outward So the flux is also outward, delta phi is also outward. We treat this outward flux as positive. This outward flux is treated as a positive. Say if I have a negative charge inside a closed surface, electric lines of force goes into the surface, normal to the surface at a given point, delta phi is inward, and that is treated as negative. That is treated as a negative. To get a flux, charge has to be inside a closed surface. Say, but I have a charge q, but it's not in a closed surface, but it's outside the closed surface. Then what happens? There is some flux, electric lines of force coming into the surface because of this charge. Not only coming, they are also going. So what is happening? The incoming flux here is equal to the outgoing flux. As incoming flux and outgoing flux are equal, what we can say is there is effectively no flux. So flux will be there in a closed surface only when the charge is inside the closed surface. If the charge is outside, due to that there is no flux at all, right? We will continue this discussion further and talk about electric flux in the further lessons. Thank you for watching.